All right, good morning. Let's get things kicked off for this month's industry hour. Today, we're going to have corrosion training from Mike Strayline at Biben Sales and John McCormack from ABB. I'm really grateful to have you guys on this morning. And I'll turn it over to you, Mike, to kick things off. Some information. If you do have any questions, please use the chat function or feel free to unmute yourself. This presentation is being recorded and will be put on our website afterwards. So with that, I'll turn it over to Mike. Thank you.
Good morning. My name is Mike Strayline. I'm with Biben Sales. I've been in the industry for about 30 years now. The last 8 I've been with Biben Sales. Obviously, we represent ABB, and today we'd like to talk about the corrosion training. I'm going to introduce John McCormack. He's our ABB regional. He's going to take the first portion of this training, and we'll go from there.
Good morning, guys. Like Mike, I'm also a veteran in the industry and have a lot of experience with industrial products in particular. So we'll start with, I'll just highlight the agenda that we're going to do. If you could go to the next slide. So we're going to do just kind of basically what is corrosion. We found out recently that it's one of the major issues that are happening in the industry, and it's actually a great solution set for our contractors because many of our customers are having many different issues that are cropping up. And what we're going to do is kind of just how to identify the corrosion besides some of the obvious stuff, material applications, codes and standards, PVC coated rigid solutions, which is one of the most popular, and stainless steel solutions. And we can obviously open it up for questions afterwards. Next slide, please. So corrosion is, it is obviously a big problem. I would say that if from a standpoint of looking at, and when you talk to your customers, especially for anybody that has service contracts with, say, a refinery or pharmaceuticals, they're always talking, this is always an issue that's coming up, food processing. And right now, recently, especially in the food and beverage area, where corrosion has occurred that is causing food contamination, it's a big deal. And it's gotten to the point where it could be something that as you address any of the work that you're doing, in particular in a service job or in a project, you can really bring a lot of value into identifying what the corrosion is and what those solutions can be. Next, please. If you see, I'm sorry, if you look at this part, you can see where the biggest annual problems occur financially in the different verticals. So for us, especially in Eastern Pennsylvania, waste treatment, utilities, and refineries are all some of the biggest guys right now that are addressing the corrosion issue, as well as the bridges and tunnels. I know there's some bridge work going on in Philly. Much of this, especially hopefully with the infrastructure authorization, we could see some really nice additional work in these kind of fields. Next, please. This kind of just gives you an impact, an idea of how impactful all this is. And, especially on the bridges, and infrastructure setups, this is like a big dollar item. Next, please. So the corrosion issue is obviously we know that it weakens electrical connections. It's obviously causes resistance, and it is a major problem. We found out in most applications about 25 to 30% of a system shutdown or failure is the result of some form of corrosion. Next, please. One of the most basic, simple things that when you think about it is that basically all metals, with the exception of gold and platinum, want to get to basically go to ground, and they want to become the oxides. They want to actually kind of blend in with the soil again with the introduction of oxygen. So that's going to be a constant, and we're just always trying to disrupt that desire to go back to ground. Next, please. These are just the basic ideas of what we need for it. You need oxygen, you need some type of liquid that has a salt or acid in it, and then electrolytes. This kind of gives you an idea of, I know it's a little primitive, but the idea that on these tubes, if you were to create a scenario, go to the next one, please, where you're seeing that the first tube would have a, say, for example, in this case, just steel nails in it with water and the availability of oxygen. That kind of gives you, the others are having, the other tubes would have similar application, but with the absence of oxygen. Next, please. This to give you kind of and I think most of you have probably seen or heard about the boneyard out in Nevada. I mean, those aluminum shelled and steel apparatus out there that are held kind of for airlines and for the U.S. military, they have no corrosion at all because of the very, very dry nature of that area compared to somewhere like San Francisco, where humidity is, north of 60%, pretty much year round. Next, please. And this is kind of, one of the things we're looking at is, which one of these would be the best material to handle the conditions. Next, please. So the materials that we utilize in the system, obviously everyone's familiar with the iron relative to rigid, steel, stainless, aluminum, PVC, and non-metallic. Right now, a majority of it is your standard rigid with the introduction of PVC coated and non-metallic. There is a little bit more aluminum being used, and stainless, believe it or not, has actually come down in price relative to what its high was, probably because there's more stainless steel production. Next, please. This gives you an idea of what you would see in your iron setup. So that would be your conduit bodies, your any of the boxes, the expansion couplings, hubs. These would all fall into that iron category. Next, please. Pros and cons. Obviously, pros, it's very cost effective. It is strong. The negative is that it's very susceptible to corrosion. And I think many of you have probably seen long-term, as that photograph shows, the long time exposure, especially something along the Delaware or even the Schuylkill. It's amazing when you see the level of corrosion. It happens in a relatively quick time frame. Next, please. And then, the rust due in the presence of air and water. Once again, we said that's that trifecta that gives it everything it needs. Next, please. Now, the ways of paint, the ways of protecting from corrosion are historic. We have paint, which is, pretty good. It lasts. It has to be reapplied often. It is something you have to consider, that when paint is used, if you're using the structure for bonding, you have to make sure that you have pierced the paint layers of paint so that you're actually getting to metal to make sure that you have your bonding, grounding secure. But that's one issue. The zinc plating, zinc is probably the most, we sometimes will call it the best sacrificial metal. So if you think of corrosion will go to attack that easiest first, the most sacrificial, which in this case is zinc. And give you, for instance, if you were to take, if any of us got to see a oil rig out in the Gulf, suspended underneath the rigs themselves, each one is basically a 1-ton block of zinc, and the corrosion attacks the zinc before it attacks the structure. Similar to, if any of you have a hot water heater, there'll be a sacrificial zinc rod inside the water heater, so it goes to that. So zinc's a big thing. The big problem we've had with zinc is that its cost is doubled probably in the last 6 years. So a ton of zinc now is about $3,200. About 4 or 5 years ago, it was about $1,500. So as it becomes more applied to more products, whether it's your furniture, your outdoor furniture, your lawnmower, and then all these things, it just is going to keep going up. But that's one of the things out there. The epoxy powder coating is great, but sometimes that's an issue because of how it has to be applied, and it only can really be done on certain products. And then, of course, the old standby is the hot dip galvanized. Next, please. So paint, as we said, forms a barrier, to getting to the iron. Next, please. It is susceptible to the environment, as we said. Corrosion only needs a weak link. We were talking earlier that, and maybe you've noticed this too, where we've seen complete structures that are PVC coated conduit, and if you squeeze the pipe, there is actually no metal left. It's just all PVC tubing, and it's the, you know, that's the kind of thing that just one little entry point will compromise the whole system. Next, please. This gives you an idea of what alloys and how they work. And for us, you know, it's in the electrical, we have the copper, brass, and bronze. And the copper is obviously the most that we deal with. Next, please. This kind of gives you an idea. It's an excellent, you know, copper's excellent conductor. And it really has all the beneficial things that we like for an electrical transfer system. Next, please. Brass, you may have seen this out there quite a bit now. There's a lot of brass fittings made by us, many other manufacturers, or brass products, and they tend to be nickel plated because brass by itself, while it's strong, it has some issues due to it's a little more, it tends to crack a little bit under stress relative to some of the other products. So we see this out here. It is something that's out there. We see more of it identified. One of our recommendations is that, you know, your first brass go-to would be nickel plated, and you can presently get much of the product's fittings with the nickel plating. Next, please. And this gives you kind of a list from the, you know, the most best sacrificial metals, which would be zinc and magnesium, all the way down to platinum and gold, which are obviously some of the worst. And we'll talk a little bit about stainless steel too, but it kind of gives you an idea of that list. And we'll make this presentation available to Rob so that he can share it with anybody that would like to. Next, please. So, you know, we go to what would be the best condition. Next, please. So as you can see, you know, gold's the best, aluminum's the least effective, and iron's a little bit behind aluminum. Next, please. This gives you an idea. The aluminum corrodes into the aluminum oxide, and that's where you see that white finish on aluminum. And it's actually a protective mode of the aluminum. But for us, from an electrical standpoint, whether it's a conductor or if it's a structure, that can cause us some problems. Next, please. Very active to the air, and you can see that's, I mean, some of the applications you've done. If you've ever done any kind of aluminum work with wires and connectors, you'll notice that we put an oxide inhibitor inside the fittings, as well as, you know, sometimes that you can paint on the wire to help present that reaction. Next, please. And as it says, it does actually give it an oxide protective layer, but overall for conductivity, it is a negative effect. Next, please. Just kind of give you an idea, like the iron zinc plating and kind of what we're doing. So we're attaching that sacrificial zinc to the iron, which, you know, once it gets through that zinc, then that's when it would attack the iron. Next, please. And this just gives you, it's a nice chart, kind of gives you an idea from a price point to and corrosion protection levels, and it gives you that idea of really what you're getting for the price and for the level of protection you're getting. Next, please. This is interesting. One of the things with, you know, as we talk about iron rust will take up more volume than the original metal structure. So that's kind of one of the reasons why the rust is generated, is that why you can't get nuts. You know, if with nut and bolt, you can't get the nuts off. It's because of the rust that's happening and expand. You know, is actually creating more space than was there before. Next, please. This gives you another thing that too, and this is another important aspect, that when you come across a possible solution for a corrosion issue, that you can go ahead and introduce, say, for example, brass or aluminum, but you have to really be concerned about the galvic corrosion that can happen. This chart's a nice chart to give you an idea that, say, one, you will have direct galvic corrosion, and three, where you have, you know, no or insignificant corrosion. And we've seen situations where folks are trying to address grounding and corrosion issues together, and then sometimes the dissimilar metals cause that issue. And I think this chart really addresses it. Also, too, we have to be careful that other trades, when you guys are obviously, we don't, none of these projects are done in a silo, and sometimes the other trades will introduce dissimilar metals into a situation, causing corrosion. Sometimes that may be out of their total ignorance of it, or it's just being applied and they obviously don't know that it's happening. Next, please. This is the big thing, and hopefully with your customers that you can approach as you either are trying to quote a job or for your service agreements, what's the environment, the materials, and to give them an idea of how long some of the stuff will last. And as Michael will address with the PVC coated, it's a very, very broad range with similar products, but just by doing some simple things, whether identifying indoor or outdoor, is concrete being used, is there a possibility of dissimilar metals? Next, please. Now I'm going to let Mike talk to you about the scenarios with the PVC coated. But any questions regarding corrosion in general? All right, well, thank you.
Okay. All right, so basically the PVC coating process for steel pipe starts with black steel, the shell of manufactured steel. ABB is the only manufacturer that actually threads their pipe before they hot dip galvanize it at 850 degrees. Basically what they do is they'll put a 2 mil urethane coating on the inside of the pipe after it's threaded and hot dipped, and then they'll do the 40 mil PVC coating on it, which is where the protection, the double protection comes in on the threads of the pipe. This is a salt test based on a 42-day salt fog test, and you'll see the salt buildup is basically what you'll get instead of corrosion, based on the fact that the pipe is hot dip galvanized and the pipe has the 2 mil coating on the inside where the threads are. The threads are the weakest point of the system. Basically, that's where moisture will usually get in, unless there's a nick or a gouge in the PVC coating. Generally, that's where the problems start. Basically, PVC coated solutions. We do a certification class for free for all contractors. I am a certified master trainer. Basically, what I do is I'll go out to our customers. We'll go to the job site. We'll go to your office. We'll do a training at my office. Anywhere it's possible to help the customer itself. And basically what that training does is it reduces the risk of liability. And when I say that, it means basically gives you the proper techniques to install the product so you don't have issues going down the line. It offers you a 5-year warranty on your work based on a 2-year product warranty that you normally receive if you're not trained. So once you're trained, you get the 5-year. The training certification lasts for 2 years through ABB's system. And then I can do recertifications after 2 years. Basically what that'll do is if you're properly trained and the system is done correctly, that'll give your basic savings of about 25 to 30% back to the ownership of your company. We offer Form 7 and Form 8 fittings through ABB. We call it a blue coat conduit bodies. Most of them are cast iron, some are aluminum, depending on the situation you're going to be in. Electro galvanized plating, the acrylic epoxy powder coating, 2.5 mils on the inside. And as you can see in some of the pictures here, how the corrosion goes versus having the same type that's actually coated. If you go here, you'll see a test that was done 500 hours, 5% solution, and you can see how our product stood up to a competitor's product. I wouldn't call out any competitor, but obviously what we do is we take it to the next level, basically, and try to make sure that our product will stand up to the elements. We offer a Corrostall version of those products. This is a typical LU product that we have. This can be offered in PVC coated, can go to Corrostall aluminum, cast iron, Form 7 and Form 8. It also goes with stainless steel. It's an LU. It's a newer product for us. It's been out on the market probably the last 5 to 7 years. Basically, it takes the place of an LB, an LL, an LR, a T, a C, an X. I mean, you can use this, not an X, but you can use this product from 4 to 5 of those different applications and save yourself on inventory at your own shop. So, conduit bodies, features and benefits. All conduit bodies have cast covers. They're use Corrostall material, aluminum material. They use stainless steel screws. I'm going to go through this kind of quickly because this is, you know, kind of jargon. Basically, our bodies are all set up for corrosion resistant applications with the stainless steel parts and the aluminum for the covers. So, Corrostall aluminum material, conduit bodies, covers. You know, it's a different level of protection with the Corrostall aluminum. It depends on the environment you're in. Like I said before, we can offer it in cast, also the steel and the stainless steel and PVC coated. Here's another test. You can see basically there's no pitting on the covers and no rust on the threads. And you'll see, and the other one, there's pitting, flaking, and the rust on the cover itself. And that's where the moisture is getting into the unit, and that's what will cause everything to fail. Stainless steel. Why stainless steel? It's basically based on the environment that you're working in. An engineer might specify stainless steel for specific types of projects. We see a lot of stainless steel in the bridge projects now based on the strut. We sell a lot of strut and strut fittings, and it goes along with the PVC coated pipe that we sell. So if we're working on a bridge project, we'll generally see all the strut straps, hangers, hardware, all that stuff will come in stainless steel because they don't want to PVC coat the pipe. There's different benefits between 304 and 316. That is all based on specification. And I guess the environment that it's in, if it's a really salty and corrosive environment, they're going to go with the 316ths. That gives you more protection and for the lifespan.
And I just wanted to add, if you don't mind, that it seems like from an industry standard, the 304 is going away.
Yes.
And it seems like things are defaulting to the 316. We just see that more requests from customers. There's not much of a price difference of any at all. So I think you guys may start to see very little 305 being used relative to the 316. So yeah, just throw that out there. And not just with us, but with anybody.
Yeah, and we're starting to see more and more stainless steel applications in food and beverage. Some of the stuff that we do in Jersey, there's a lot of applications for food and beverage of wash down for stainless steel. So that's a you know, really going forward. There was a time where they were using PVC coated rigid with white coating on it so they can sense bacteria, but now they're going to stainless steel because it doesn't bacteria won't grow on it. So we can sell straight sections. We have, you know, all different types of products between the nipples and the elbows and the couplings for stainless steel. You know, we do the 304 and the 316 in the pipe. Right now, I think, like John said, we'll probably go away from that more to the 316ths. It's just you know, industry is changing. So they offer all the conduit bodies and all of the different types of fittings in this stainless steel. Like I stated before, the LU takes up the place of most of the other products. So you can buy one LU to take the place of most of the others, which will eliminate inventory for some distributors, and you know, it'll help contractors in the long run. They'll be able to keep one product on the truck, offer a better solution also. 16s. Metal alloy with a minimum of 11% chromium helps with iron from rusting. high corrosion resistance and chemical resistance with strength, durability, ease of installation, and low maintenance. Withstands high temperatures. No pores, no cracks, meaning it's extremely hygienic surfaces, meaning we can do that in pharmaceutical applications and in food and beverage applications. Some of the guys that do those types of work are starting to move to stainless steel just for those applications. This is just a chart to show you some chemical performance ratings for stainless steel. Obviously, there's the differences between 304 and 316 aren't very much, but there are some differences here and there. This is for dissimilar metals. Obviously, aluminum works well with stainless steel, but it's not, it has a insignificant factor of the galvanic corrosion, but it still works better in that application. Others like brass and bronze and copper don't work well with stainless steel. And as you can see on the chart on the side, it shows you which the products are. You get I guess as I would say, it's a high tensile strength. Stainless steel is a lot stronger than most other materials. It handles high temperatures better in high temp applications, wash down, low temperatures and really cold environments. It handles well. So stainless steel is probably the number one. Going back to OCal though, OCal products, you need to look at your environment where you're going to use stainless steel and you're going to use an OCal product. The OCal or the PVC coated, I should say, is a less expensive solution to a problem. And if you look at an environment, some engineers might say, well, you need 304 stainless steel. Well, sometimes you might be able to say, well, we're not in that corrosive environment. Can we use a protected material like PVC coated in those applications and offer your engineer a solution and actually reduce the cost of the project and reduce your cost at the same time? So benefits of the stainless steel. Obviously, we talked about high corrosion resistance, high chemical resistance, strong and durable, ease of installation, maintenance, high temperature and low temperature, no pores, no cracks. Dollars, it's up there. It's a very expensive proposition when you get into stainless steel. These are some ideal applications for stainless steel, some different types of environments that are very high caustic areas. But in a lot of these same situations, we use PVC coated and we use rigid pipe also. So if you look at all the different environments that they're in, you're going to have to best figure out. And I've seen this in many cases where we'll go and look at a project. I'll go to a refinery or I'll go to a mining facility. I'll go to a quarry, and they are using rigid material and they have to replace it every 5 to 7 years. And it costs them way more money than it would have if they had actually used a PVC coated product or a stainless steel product in those environments. And a lot of those environments aren't regulated by, UL. They're just moving equipment and then they're just installing and they're buying the cheapest product they can and then putting it on. So that it makes it difficult. So, but as a contractor or us, if we are brought in on a project, we can recommend a better product to make sure that lasts and there's minimal expense to the customer. And this is just a couple of differences between the 316 and 304. Basically, it's chemical composition and a little bit of temperatures. Not very much, but enough, significant enough that it can cause problems in a different environment. And here we go with another comparison of the price. We'll talk about stainless steels at one end. You have galvanized steel at the other. Aluminum and PVC coated are right in the middle. They tend to be the most popular based on the environments that we've been quoting on. UL White Book guidelines. I'm not going to go through the whole thing, but obviously it's important to follow the UL standards so that you don't, lose your warranty on product and things of that nature. And PVC coated applications, good and bad. Like we've been talking about, it talks about the environment. What are great applications for that material? When would I not use that material, or would I use stainless steel? These are things that you have to navigate. And I actually have a chart, which I'll supply Rob. I'll supply to you. It gives you the environments that you'd want to put stainless steel in. It gives you the environment you'd use PVC coated, and it gives you an environment that you'd use rigid. And it gives you a rule of thumb of what environments they should be in, and for that matter. Financial benefits over stainless steel 304 and 316 with PVC coated products, wash down and outdoors, NEMA 4X, Form 8 conduit bodies. You can do projects with custom colors. We do the Walt Whitman Bridge color, which is at powder blue. We're working on a project right now for another job for Northampton Street Bridge, which shows a green color so that it matches the green of the bridge. Ben Franklin Bridge is also a green color, so we do custom colors. We use Ocal White for Merck applications for pharmaceutical. So if we need to do a custom color for a project, we can. What I do say is we have a color chart that we have basically that can tell you which color you want to go with, and we'll do it that way too. Environments like the wastewater treatment plants, we do a lot of that. We do bridges, different environments, salty environments down by the shore, food processing, oil and gas. Here's just a chart to show you the application areas that we've been in and where these things are going to go. This just shows you, I think this slide is from 2018, John, am I correct? Yeah, so this slide is probably a little off in the number wise, but to give you a general idea how much money is being spent on PVC coated applications in these environments. So there's a large amount of money. If you just look at wastewater treatment, it says it's 36 billion that was spent for wastewater treatment plants. So there is a lot of money in these products. When not to use PVC coated materials. In a dust environment like some mining facilities and areas where there's a lot of dust, you'll get a possibility of static discharge. So that'll cause problems with electrocution of other situations if there's ever a fault in the system. Tunnels, we don't want to use in tunnels because PVC coating has a toxic burning smell. So if it was in the tunnel, we don't want to do that because we don't have that issue if anything ever happened inside of a tunnel. And boiling water, I'm not sure where we have any boiling water in our area, but there could be some applications where there's some water treatment where they're boiling water and they don't want to use it in that area because they don't want to melt the PVC. Obviously, strut applications we talked about, we generally move to stainless steel. When we talk about strut applications, we do PVC coated strut, but it is not as efficient as the stainless steel, and we will always recommend the stainless steel over the PVC coated. And this is just a chart that when would I not use those materials, and it'll basically give you an idea of those applications. What are other considerations in the selection of the material? Well, it's based on your value engineering, your FRE, HDG, conduit and conduit types, and aluminum, whether it's made in America. We can do made in America Ocal PVC coated pipe. There is a significant cost increase in that because we have to buy the materials from a different manufacturer within the United States that makes American made pipe, and the process is completely different. Is the same to dip the pipe, but the cost of the made in America pipe is slightly different than what we do in raw materials from other areas. The non-metallic fittings, XD fitting, is compatible with the FRE. Installation costs, basic, necessities like you got cranes on site, and the to install PVC coated steel and aluminum. Electricians should be certified for installation. That doesn't mean they have to be. You're only getting a 2-year warranty if you're not certified. But if you have certified installers, you're going to get a 5-year warranty. And then BIM modeling, we can do that also. And that's about it for that. And we can open it up for questions if you like.
All right, thanks, guys. Please feel free to unmute yourself if you have any questions or use the chat feature. We'll just give it a minute and see if anybody has a question.
Like I stated earlier, I am the certified OCal master trainer in the area. If anyone wants to reach out to me privately, they can. Obviously, Rob, I believe you sent out our email addresses with this presentation. We'll send it out with our presentation. I'm local, so if you need me to come to your office and sit down and go through some stuff, not a problem. I cover the Philadelphia, Delaware, South Jersey market, so I'm very accessible.
Great. So hearing no questions, moving forward, I will send a follow-up email with Mike and John's contact information, as well as the presentation here, and I believe a chart that Mike will be sharing with me. Really want to thank everybody for hopping on this morning, and looking forward to December Industry Hour. We'll be with Jim Matthews from Fox Rothschild. We'll be giving part 2 of the emergency temporary standard on vaccine mandates. So thanks again for everybody hopping on, and I hope you all have a great day.